This engine starts as stone.
First, the rock must be broken.
Explosives free the ore. Next, the metal must be separated. Crushed ore is reduced again.
Screening keeps the size consistent.
Grinding releases the metal particles. At the mill outlet, the slurry flows into a sump tank fitted with agitators preventing settling, while pumps push it forward through pipes.
The camera follows the pipeline into a hydrocyclone cluster, where the slurry enters at high pressure and spins inside conical separators.
Now the iron can be separated.
Magnets pull the iron out.
Waste rock is discarded. Water is removed from the concentrate. The purified ore is ready for smelting. Powdered ore is shaped into pellets. Pellets must be hardened. Consistent size ensures stable melting. Fuel and flux join the ore.
The ore enters extreme heat.
Liquid iron forms at the bottom.
Molten iron moves to steelmaking. Composition is checked before refining.
The contained material remains liquid pig iron, prepared for conversion into steel in the next operation. Refining because
Molten iron is refined into steel. Oxygen removes carbon and impurities.
When blowing stops, the vessel tilts and slag flows out into a slag pot before clean metal remains inside.
Clean steel is tapped.
Inside is homogenized molten steel, bright glowing liquid circulating gently within the container, because uniform chemistry prevents weak spots.
Composition confirmed for casting.
Steel begins to solidify.
The tundish releases metal into a water-cooled copper mold. Inside, a partially solidified steel shell forms.
Liquid metal becomes solid steel.
At the straightening section, large rollers guide the strand from vertical to horizontal orientation while maintaining steady motion.
Billets are cut to size.
The blocks move to forming.
So the steel is reheated for shaping.
Pressure forms the rough block. Excess metal is removed.
Machining starts by creating flat reference surfaces. All sides are squared and aligned. Large cavities are opened.
Next, a slot milling cutter carves channels along the side of the block, creating coolant passages and mounting grooves. The
block is cleaned for precision cutting. Precision machining defines the engine block. Cylinder diameters are precisely controlled. Honing creates the sealing surface.
The component becomes engine block with machined crankshaft bearing journals precisely aligned along the lower housing.
Machining is complete.
The camera stops beside a sealed washing cabinet where multiple blocks enter a spray cleaning cycle, removing residual coolant and metal particles.
Heat treatment strengthens the metal. Cooling locks in strength. Protective coating prevents corrosion.
Final measurements are verified. Final measurements are verified.
The engine begins assembly inside the block. The crankshaft is installed. Pistons move inside the cylinders.
Next, an oil pump module is installed at the lower section of the block and secured with bolts, while a pickup tube enters the oil sump cavity.
The engine is sealed together.
The resultant assembly becomes engine block and cylinder head permanently fastened, forming a sealed combustion chamber housing.
Camshafts control the valves.
At the front section, a timing chain is installed, connecting the crankshaft gear and camshaft gear, while tensioners lock it in place.
Air and exhaust paths are installed.
A fuel injection rail mounted along the intake side and connected to ports aligned with each cylinder. The controlled fuel supply powers combustion.
Every engine is tested.
Ready for installation in a vehicle.